Hey guys, it's week number 8 of preparing for professional data engineering exam on Google Cloud. If you watched the previous videos, then you already know that the week is an artificial construct, meaning since the last video, I think it has been about a month or even more. So it's just week number 8, meaning the video number 8. In reality, it takes me much more time than just 1 week to do the following things in this course. And let's go straight to the topic. So this week was about, again, data flow. I really like this tool, in quotes, of course, because when I'm doing this learning path, so much time goes into this specific tool. And I'm not sure how I feel about it because I've been working as a data engineer for more than 5 years already. And to be fair, in all companies where I've worked, we have never used data flow. So I'm not sure which conclusions should I make from it, but it seems like it's not super popular. But it really seems that Google wants very much for us to use data flow as a main tool for building batch and streaming data pipelines on GCP. For some reason, it kind of feels a bit old, outdated, not really modern. I'm not sure, maybe it's because I'm not such an experienced data engineer, and maybe that's why I feel that way. But yeah, that's just a feeling that I get. Nevertheless, it's a part of the certification, so it's not like I have a choice to skip it completely. So during this artificial week number 8, I have completed 2 huge courses on the data flow. One was more than 20 hours of content, including labs, and another one I think was stated as 14 hours of content. In reality, again, I'll just mention that it's not like really 20 hours and 14 hours. Of course, it's more fast, so it's like a rough estimate how much it can take. But indeed, it took quite a while because these courses are huge and they go in depth on data flow. Before doing them, my understanding of data flow was extremely tiny. Now I would say it's kind of like a medium level. I'm still not an expert because candidly, I haven't learned it separately a lot and haven't done like a hands-on practice outside of quick labs that I have as a part of this course. I have done some extra research to understand topics that were hard for me to grasp. It helped, yes, but I didn't practice a lot separately. So that's why I'm saying that still my knowledge of data flow is kind of medium. However, to be fully transparent and to give credit where it's due, I did improve a lot because when I was going into these courses, my knowledge was very tiny. I also rate these courses that I complete like on a scale from 1 to 10. It's a bit hard to do that with these courses, but I think I'll give it a 7. I'm saying it right away and not in the end of the video because there is no point in waiting because these courses were so hard and I wouldn't like put a lot of emphasis on my grade here because yeah, it's just how I feel, but they were too big for me to give an accurate mark. Why 8? Because as I said, my knowledge did improve. It took a lot of time. Again, not all labs were working. Those that were not working were mainly because of the availability of the resources in the certain zone. So when I tried to run the data flow job in a certain region according to lab instructions, it just failed to start because probably there was no capacity for the jobs coming from learning quick labs to run in the region. So now as a learning method of reinforcement, I'll go through the list of things that I have learned in the past several weeks when doing these courses. All right. The first one is data flow windowing. It's a concept used in streaming pipelines to group unbounded stream of data, to give it like boundaries, to be able to aggregate it and to calculate certain statistics or do whatever we want, not just on record per record, but on a certain group of records. So there are 4 types. The first one and the simplest one is fixed windows. So fixed windows are fixed time frames, and the events that arrive within these fixed time frames are being grouped together. So for example, we say that we want a fixed window of 1 minute. It means that, for example, between 13:01 and 13:02, all events that will arrive between this time frame, they will all be grouped together and processed together, and we can do aggregations on them or whatever, but they are considered like one window. So if event arrives at 13:01 10 seconds, it will wait until the 13:02, and for all events that will arrive within time frame. So it will kind of be persisted in memory, and only then when this window is the end of this window is reached, all of them will be processed together. Then we have sliding windows. These are very similar to fixed ones, but they slide. So for example, we can have 1 minute sliding window, and it will slide every 10 seconds. To give an example, let's say we have a 1 hour sliding window that slides every 10 minutes. So we have a window from 1 p.m. till 2 p.m. and the next window would be from 1 p.m. 10 minutes until 2 p.m. 10 minutes. Third window would be from 1 p.m. 20 minutes and till 2 p.m. 20 minutes, and so on. So we have this 1 hour window and it slides, and we calculate like the moving average here. The next type of windows is a session window. It's a special kind. It's different from sliding and fixed windows because it's based on the underlying data. For example, if we have a user session on the website and we want to track their activity, what they do, it doesn't really make sense to use fixed or sliding windows here. We want to track the user activity based on the user ID. So as long as events for this user ID are coming in our data pipeline, the window will wait for them until they arrive. And for example, we can have a condition that we will wait, let's say, for 30 minutes. If there is not a single new event, then it makes sense to close that session window. The final type of windows is a global window. In Apache Beam, everything like needs to have a window. So even batch jobs, non-streaming jobs, they also have a window, but this implicit global window. And when we don't specify the window, even in streaming pipelines, implicitly the global window is used. It's like a boundless window. It just exists there, but in reality, directly, I think you will not use it, especially in streaming pipelines. But I'm not an expert here, so I could be saying just some bullshit about global windows. I'm sorry for that. Good. And side note I have here about Windows is about terminology, because a part of the preparation for this exam is doing the quizzes, tests, and often in quizzes they name the windows differently. So they use a term tumbling window and hopping window. So tumbling window is the same as fixed window, and hopping window is the same as sliding window. That part was a bit confusing to me when I first encountered it after like watching the course where they name it fixed windows, but in exam it can be tumbling windows. Yeah, that's how it is. Just remember it. The next point is event time and processing time. This is actually a pretty easy concept. Event time is the time when the actual event happens. For example, if we have an IoT device that sends data to our pipeline somehow via the internet, and the event time would be the time on the device when the actual event happened, or whatever, event on the website, or it doesn't matter. And processing time is the time when this event arrives to our data flow job, or like whatever service that processes this event. So these two concepts are universal. They don't exist just in data flow, but in general, and they're pretty easy. So event time, when the actual event happened, processing time, when our processing service received this event. And as you can imagine, in real life, there can be, and probably always is, this lag between the event time and processing time because of the network delays, whatever, outages, or like even without outages, just the time to travel through a network takes milliseconds. So these are the two core concepts that are used a lot in streaming. The next one is the one that I've struggled a bit, the watermark. The watermark is an estimate, or like an educated guess, after which time the system can say that there should be no events earlier than the given time. It is done based on the combination of processing time and event time. So watermark can be calculated at least in two ways. The first one is fixed. It means that I, as a programmer, can specify that I expect data to be seen at most 30 seconds late. Anything after that would be considered a late message. So watermark is kind of a way the pipeline, the data flow, Apache Beam tries to stamp the data to understand that there shouldn't be anything arriving prior to that point in time. Another type how it can be calculated is called source-based. So with services like PubSub and Kafka, watermark gets calculated based on the event's oldest unacknowledged message. So if you have worked before with these systems, then you know what I'm talking about. So when our pipeline receives a event from PubSub, for example, once it gets processed, the pipeline service acknowledges that this event was processed, and then it gets cleared from the PubSub. So based on the oldest unacknowledged event sitting in PubSub, the Apache Beam calculates the watermark. So it thinks that there shouldn't be any new messages coming prior to that oldest message that sits in the messaging system. It's a bit confusing. I hope I understand it correctly now, but yeah, I wouldn't rely on what I've just said as a ultimate source of truth. Next concept is lag. This one is pretty easy. Lag is a processing time minus event time, and that gives us how much time passed from the moment that event happened until we have received it. So we can see a network latency happening here, or whatever are the reasons for this delay between event time and processing time. Then allowed lateness. It's the time frame when we still expect the late data, when we kind of consider that it's still okay. Like, you are late, but it's okay, come in. And if the data arrives within this allowed lateness time frame, it will still be processed. If it arrives after that allowed lateness time frame, it's gonna be discarded. So it's kind of a way for us to specify which logic do we want to apply for such late events, and how long this allowed lateness is. So for example, we can have it like 1 day, 1 hour, 1 minute, 10 minutes, whatever. So yeah, and data flow will still accept these events coming late. Point number 6 is about the lab that I really liked. It was about the monitoring and alerting for data flow jobs with email notification. I found it pretty useful, mainly because alerting and monitoring on Google Cloud is something that I plan to explore in depth pretty soon, because it's something that I think I could utilize during my day-to-day job, and we could leverage it more because it provides cool features like defining custom metrics or creating alerts based on certain metrics of the services in Google Cloud that we use. And Dataflow is no exception. So alerting and monitoring can be set up for Dataflow jobs, and you can receive notifications when something goes wrong or some metric falls out of expected values. It can open the incidents when something bad happens, and you can like resolve them, document them. Yeah, a pretty powerful feature. I think it's worth exploring it in more detail, so I liked it. Then there was a module about testing Dataflow pipelines, how you can write unit tests and integration tests for Dataflow pipelines, and how you can use the direct runner, the runner that like can run on your machine to do tests. And yeah, a bunch of best practices about tests, which I have already forgot. So yeah, but I think it was also pretty useful. Then there was a module about Dataflow templates. It's like a way how you can define a reusable Dataflow job. There is a bunch of predefined templates created by Google, and you can reuse them. For example, PubSub to BigQuery, PubSub to Cloud Storage, or a bunch of other templates. So essentially, there they explained how to create a reusable job template and how to use it. And as a final point, they have here a mix of things, like different concepts that I think could come up in certification. Some things about regional and zonal availability, reliability. So for example, if you create a job in the Dataflow job in a certain region, most likely you don't want to specify the zone, because it gives you the ability to rely on Google to come up with the zone within a region that has the highest level of availability when you launch the job. And I think I saw some questions specifically about that in quizzes. And there were a bunch of other best practices about creating production-grade Dataflow jobs. It's kind of hard to apply them unless you have a strong foundational knowledge, but I hope I remember at least something, and when the time comes, I should be able to use it. And this is it. It was an artificial week number 8. I think at this point, finally the courses about Dataflow should stop. I don't have like in front of me right now the learning path, but if I remember correctly, it should have been the last course about Dataflow. And overall, I think I'm done with about 75-80% of the course, and there are just a few smaller ones left. I'm excited to finish them as soon as possible and start practicing for quizzes and tests for the actual certification, because it's not like I have a lot of time. I have already registered for the exam. I have about 20 days left, which is not a lot, because it's not like 20 days when I can prepare the full day. Not a lot of time left. Sadly, I didn't have a chance to schedule it for later because of reasons, but now I have to deal with what I have, and I'll try to do my best to pass this exam. If I don't, you will also know it, because because why not? It's life, it happens, and it's normal if you don't pass the exam from the first attempt. But nevertheless, I'll do my best to do it. Thank you so much for watching, and see you in the next one. Bye bye.